Hi everyone, my name is Hiroshi Suzuki and thank you for watching my presentation. This is a presentation to introduce a new tool, CTO or Code Tree Overviewer. I hope you like it. First, let me introduce myself. My name is Hiroshi Suzuki, working for Internet Initiative Japan or IIJ. IIJ is a Japanese ISP and we are the first commercial ISP in Japan. I belong to the CSAT team, IIJ Sect. I'm a malware analyst, a forensic investigator, and a researcher. I have been a speaker at Black Hat USA, Europe, and Asia. And I've also been a trainer at Black Hat USA since 2018. What I'm talking about in this presentation is what CTO is. CTO is an abbreviation for Code Tree Overviewer. The main purpose of it is to visualize a function code tree like this figure. This is the CTO window. You can launch it by pressing Alt plus Shift plus C. Then CTO will show a function code tree based on the address on IW here. This is the target address. You can expand the tree by double-clicking this type of node here, like this. And you can also filter nodes by double-clicking a node like this. CTO can also show us summarized information such as function calls, string references, structure member accesses, and comments in a function. You can get the summarized information at once by pointing the mouse cursor on a function, like this. And CTO can also find a path to or path from a function. Get arguments of unresolved indirect calls by applying type information. Collect other tools results such as iron strings and find crypt.py and so on. I hope you like it. By the way, this cheap icon is the icon of CTO. It's getting funnier and funnier, right? Anyway, let me explain why I developed CTO first. IDAPRO already has two function code tree related features. One is called graphs or chat feature, and another one is called proximity browser. Despite of them, why did I decided to develop this plugin, CTO? First, let's see graphs feature. It can create cross-references to or xrefs from graphs, or custom graphs for both ways with data xrefs. For example, you can create a graph like this way. This is a graph here. However, this is not a clickable graph here. So you will need to create the graph again if you want to check another graph with a different condition. As you see, it has also unnecessary data references, especially until IDA 7.5, which was the latest version that I decided to develop CTO. This feature always traced all xrefs, and it always creates complicated graph. The other one is proximity browser. It was implemented in IDA 6.2. It can create a clickable graph, and it also has filter and find path feature as well. Let's see the feature. You can display it by going to View, Open Subview, Proximity Browser here. Right? And it can also synchronize with IW like this way. Then if you click a node, you can jump to the address like this. This is very useful. However, it tends to follow unnecessary paths and xrefs. For example, you can see proximity browser shows us two paths for this function, right? However, when you check cross-references with IDA, you can see there are two cross-references, right? But they come from the same function that ends with 2190, right? 2190. So it means this path, right? So we have another path here. So I don't need this path, I think. But since proximity browser displays this unnecessary node, so I need to check all the paths like in this situation, like this. But I think it's a meaningless code here, so I don't need this path. Yeah, this behavior annoys me. In this figure, you can also see proximity browser shows four paths here. But actually, IDA has only one xref here. Proximity browser shows us unnecessary xrefs in this situation as well. Furthermore, proximity browser always displays all types of nodes. The figure here shows us proximity browser displays a string node and a global variable node, right? Large number of nodes makes us difficult to understand the relationships due to the complexity. Although you can filter these nodes from a context menu, that's a hassle for me to filter every node one by one. Those disadvantages made me to develop CTO. Here, I will introduce CTO from now on. There are two CTO-related widgets, this one and this one. This is the CTO's main window. You can check graphical code tree here. And another widget is CTO function lister. It's a helper widget for CTO, although it works as a standalone too. Here, let me explain CTO function lister first. This is the CTO function lister window. You can think this is an enhanced version of functions window. Here, this is the original version of functions window, and this is the CTO function lister here. It lists functions with some important information such as function calls. Yeah, this is a parent function and child functions here. And global or static variables here, and strings references, and possible structure member accesses in a function, and you can see every function. This is useful for enumerating all structure offset references. And you can also use a regex filter to find nodes with a specific pattern. For example, if you input create file here, then you can check all functions that refer to create file W API, right? Or create file A API, like this. Or you can also use a regex pattern. For example, you can input like this pattern. Then you can check all possible structure member accesses, like this way, right? This is useful for enumerating all structure offset references, right? Anyway, this is the CTO function lister. Next, let me explain CTO's main window here. At first, CTO only shows us function nodes by default to keep the graph simple, and it shows the target function at the center of the graph here, and a layer of parent functions here, and a layer of child functions here. As I mentioned earlier, we can expand the tree by double-clicking this type of node like this. And then you can check additional layers of functions. By default, CTO shows caller nodes as well as callee nodes, like this. Surrounded by red boxes are Cora nodes here, these ones, and blue box is a Cori nodes. This layout is very useful because we can check code around the node in IDA view by clicking a Cora node, since CTO synchronizes the address with IDA. But if you don't need Cora nodes, you can omit all of them by pressing A key on the CTO's window like this. This is useful if you want to grasp function relationships, since you can keep the graph simpler than the previous one, right? And you can, of course, change back to the previous mode by pressing A key again here, like this. You can choose the layout depending on the situation, right? But this mode, I call it Cora mode, is useful for checking code in a function. As I mentioned earlier, if you click a Cora node like this, IDA view will jump to the Cora address like this, right? This code clearly indicates that it reads a file, right? Because read file API and create file with generic read flag, right? As I mentioned earlier, CTO shows only Cori and Cora nodes by default to keep the graph simple. But if you want to display other types of nodes, such as string references and global variable references, you can do it by pressing a shortcut key. For example, if you press Alt plus S keys, you will see a string references here. Then, you can check the string references here. lsas.exe, right? Since this function has a reference to lsas.exe string, as well as create two help 32 snapshot and process 32 first, process 32 next APIs, you will easily find that this function finds the LSAS process on the process list, right? By default, CTO will stop tracing functions beyond a static linked library function to keep the graph simple, like this and this. It's because in most cases, we don't need to trace inside static linked library functions. However, if you want to check inside the functions, you can dig into this type of node here, like this. And by default, CTO omits child nodes in parent functions because if you display such nodes, the graph will easily be too complex. These are the parent functions of the target function. CTO omits child nodes in the parent functions except for related to the target function. It means these are related to the target function. For me, I don't need all child nodes in parent functions because I want to check only parent functions related to the target node. But if you want to check them in spite of it, you can display them by pressing the P key here on the keyboard. Then you can display all the child functions in parent functions. This is one of the parent functions, and these are the child functions in this parent function. So there are many nodes, right? Although it has a large number of nodes and it's too complex for me, you can check all nodes at once if you want. And of course, you can hide them again by pressing the P key again, like this. And if you don't display child nodes in parent functions, you can still check all kinds of node information in a parent function by pointing the mouse cursor to a function like this. You can check all kinds of information in a function as a hint like this, right? However, you cannot access the information because it's just a value hint, right? If you want to access the information, you can dump the information to the output window. Here, this is the output window, by pressing Shift plus P keys, like this. here, this information is the same as this balloon hint, right? You can go to an address if you click one of them, like this. Here, right? So you can access the information. And CTO can also display repeatable comments as nodes, which are added by a user typically. And CTO can also display specific regular comments, which are added by specific tools. For example, CTO can correct the comments generated by ion strings maintained by FireEye Flare team. Yeah. You can display the comments by pressing O key like this. Here in this function, you can find this ion string, msc main.stb, and this backslash app patch, right? These ones, right? These strings are a possible file name and a part of a file path, right? And you can also see get Windows directory W and snw printf and its format, right? So you can easily guess this function is to get a file path. And actually, this function is to create the configuration file path of this malware. Next, CTO can also create a graph to find path to or find path from a node. For example, this function calls createFileW API, right? So let's check the path to the API. We can create the graph by right-clicking the API node and choose Find Path to this node. Then you can check the path here. Right? Now you can easily understand there are three paths here. One is from inside a static linked library function, and the others are two entry points. Right? IDA's proximity browser cannot create a graph based on an API address and cannot find path for undisplayed nodes. So this is also one of the advantages of CTO. And this is a subgraph here. So you can keep the original CTO's graph you are looking at like this. Right? While focusing on the CTO window, you can still use several IDAS shortcuts. For example, you can use X key to display xrefs. And you can also use N key to rename the function or a variable. If you rename the function name, the information will be updated like this. And comment like this here, right? So you don't need to change the window focus to IDA every time. And CTO also has a feature to apply a function definition or a type information to an unresolved call. If you set an API name as a comment on an unresolved indirect call, CTO will set its argument on IDA view, like this. For example, this function has an indirect call here, right? If you set a comment, right process memory here, then you will find its argument on IDA view window, since CTO will set the function definition or typed information to the address. Then you can easily understand around the API call with these arguments, right? These are the basic usage of CTO and features of CTO. From now on, I'll briefly introduce inside CTO. It will be helpful when developing a plugin like CTO. CTO utilizes 3 classes on IDA's plugin APIs. One is UIHooks class for hooking UI events, and another one is viewhooks class to synchronize the address with IDA view. These classes come from IDA-convin.py. And the last one is graph viewer class from IDA-graph.py. This is the core class of CTO. CTO inherits this class to create a graph. So let's see the classes more detail a bit. First, UI hooks. By using this class, we can catch all UI events, which are called actions by xrefs. Let me show you a quick demo. If you select a variable, if you select a variable and press N key on it, then here make name action will be issued in that case. And you can also check all registered actions by executing get registered actions API on IDA-convin.py, like this one. Get registered actions. If you execute this script, then you can get all the registered actions here, right? You can hook these actions by using this class. CTO inherits this class to update node information on CTO by overwriting these methods. CTO compares the result of pre-process action with the result of post-process action by hooking them and checking the difference between them. And updating actions is also used to update the information that the post-process action uses. As I mentioned earlier, if you set API name as a comment like this, CTO will make IDA to set its argument as comments. This feature is implemented by catching the make comment event. Next, let me introduce viewhooks class. CTO utilizes the viewhooks class to synchronize a CTO's node with the address in IDA view. CTO observes location change events by overwriting viewLockChanged method in this class. As I mentioned earlier, if you click a CTO's node, like this, the cursor on IDA view will move to the address like this, right? On the other hand, if you click an address on IDA view, which is also included in CTO's window, CTO will color the node like this, right? This feature is implemented by hooking the viewhooks class. The last one is graph viewer class. CTO inherits this class to create a call tree graph. We can create a graph by overwriting add node method to add a box called a node, and the add edge method to add an arrow connector called an edge. We can also hook many events on our widget as well. For example, we can hook keyboard events by overwriting onViewKeyDown method of this class. And CTO overrides this to implement shortcut keys of CTO. We can also hook mouse events with these methods. By the way, let me explain jump to API as well. Yeah, I know you already know jump to API if you have ever scripted on IDA. And I know you already know that first argument of it is EA or effective address. However, how many guys do you know the second argument and the argument after that? And how many guys do you know there is one more definition of jump to API? If you don't know about that, and if you want to tweak the cursor position of IDA, the information is useful. Yeah. If you use jump to API, for example, let me show you a quick demo. If you use jump to API with an EA, for example, this is the address of the first function here. So if you execute this API, it points to the first instruction of the function, right? And if you press N key on it, you can rename the function since it points to the head of the function, right? However, actually it has a problem. If the cursor points to in the middle of instruction, for example like this, and then execute the same API again, and press N key again to rename the function. However, in this case, you will see a different dialog for renaming an argument like this, because the cursor accidentally points to the argument of the function at this time, right? Yeah, in order to avoid that, CTO use another definition of jump to API. According to idacanwin.py, there are two definitions of jump to API. The former definition can be used for jumping in the middle of an instruction on the given address. If you pass the second argument opnum, that is operand number, you can easily tweak the horizontal position of the cursor. On the other hand, if you want to move the cursor vertically and or horizontally, you can use the second definition of the API here. By using these APIs, CTO tweaks the cursor position. For example, if you select a function address like this, CTO points to the function name instead of the first instruction here, right? With the second definition of the jump to API. Yeah, and if you click instruction node like this, CTO will tweak the horizontal position and it points to a variable name. Then you can rename the function from the CTO's window like this, right? Like this. Yeah, I briefly explained inside CTO. Now let me summarize this presentation. CTO is an IDA Pro plugin for visualizing function call tree. You can grasp function relationships. You can check important information such as child and parent functions, strings, global or static variables, structure offsets, comments, and so on. You can also find path to or path from a function, and so on. I will extend some more features, for example, collaborating with some more tools, collecting more instructions to be observed, implementing more efficient way to collect path, enhancing the speed, improving stability, and so on. I'll disclose the source code in this URL. Check this URL if you are interested in. That's it for this presentation. I hope you like CTO. I hope CTO helps your analysis, and I hope CTO will inspire you to develop new scripts or plugins in the future. Thank you for watching my presentation. See you.